the distance around a figure, and you know all those old army spy movies and stuff, they're like, walk the perimeter. It goes around the outside. Yeah. So perimeter goes around the outside of a shape. And it's the total of all sides. Okay, that's the perimeter. And circles only have one side, so they have a special name for perimeter, and that's their circumference. So, okay, so L for length, W for width. So you have 2 lengths and 2 widths. So the formula is 2 times the length plus 2 times the width. Or again, you can just add up length plus width plus length plus width, add up all the sides. Yes?
Everything you're teaching today, we can go back to this book to listen to.
Yes. Squares, because squares, all the sides are the same. So you have 4 of the same length, so you can multiply times 4. Triangle, you literally can only add up all the sides. There is no other formula for the perimeter of a triangle. And then circumference, you do need to know this formula. Every other shape, you can just remember that the perimeter is to add up all the sides, but circles only have the one side, so you can't add up all the sides. You have to have this formula. R is the radius. Okay, which is 1/2 of the diameter. And the diameter goes all the way across the circle. And pi is 3.1415, you know, blah, 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 forever and ever and ever without end, random numbers until eternity. You do not need to know more than 2. Very rarely would you ever do math requiring more than just 2 digits of pi, so just 3.14. If it helps you remember, March 14th is Pi Day. March 14th, Pi Day. This rectangle. Now again, we can use the formula, or we can add up all the sides. Opposite sides of a rectangle are always the same length. So if you want to use the add up all the sides, you can just copy over. Or if you're using the formula, we have 2 times the length and 2 times the width, and really it does not matter which one is the length and which one is the width. So I have 11 plus 6.2. So my perimeter is going to be 17.2 feet. Then we have a circumference of a circle, and 6 centimeters, that's R. It's halfway across the circle. And our formula is 2 pi r. So 2 times 3.14 times 6, which is 6.28 times 6. And that one I don't have rapidly in my head. And that's centimeters. Area is the number of square units that can be enclosed within the figure. Another way to describe it is the amount of space something takes up. Two-dimensional space. Ooh, stop doing that. Two-dimensionally. (2D) is flat, like pieces of paper. So area is the amount of 2D space something takes up, so flat area or flat space. Area of a square is length times width, or sorry, rectangle, length times width. Area of a square is also length times width, but because length and width are the same thing, it ends up being side squared. But if you don't want to have to memorize two things, you can still have it length times width, just knowing that the length and the width are equal to each other. Because squares are rectangles, they're just special rectangles. Parallelogram is base times height. And you'll always know the height because height will usually, well, not usually, will always be indicated with a dotted line. Most often inside the parallelogram. It can also, though, be listed outside the parallelogram like this. But it'll always be a dotted line, and then there'll be a little 90-degree angle indicator. So it can be inside or outside. It's base times height. This length is base, and this length here is the same. It's also a base. So it can be either one of these lengths. Height is always indicated with a dotted line and a right angle square. This square right here tells me it's a right angle. And height always happens at a right angle. And
Base times height.
yes, so it's base times height. And the height can be inside, it can be drawn inside the parallelogram, but it could also be drawn outside the parallelogram. Okay, area of a triangle is 1/2 base times height, or you can also think of it as base times height divided by 2. Same thing. Half is to divide by 2. So if you don't like multiplying by fractions, even though it's just a half, but you don't like it, then you can divide by 2. Trapezoids. Trapezoids have one of the more complex area formulas. It's 1/2 the top and bottom added together times the height, or again, if you don't like, yeah, you can divide by 2. Okay, now the bases on a trapezoid, so these B's stand for bases. The bases are parallel. So that way you'll know which two lengths are the bases. The bases will never be these sides that point in towards each other. The bases will always be the two sides that are completely parallel. So if I were to give you a trapezoid and I labeled all the sides and I told you this length and that length, don't get confused and think you need to use those two. Sometimes you'll be given extra information that you don't need. And then the formula for the area of a circle is pi r squared, which is 3.14 times r times r. First of all, the area of a trapezoid is base times height, or sorry, parallelogram is base times height. Our base is 4.4, or sorry, 4 1/4, and our height is 2.5. And do you guys remember what we have to do to mix numbers before we can multiply them? Yeah, you cannot multiply mixed numbers. So you have a choice. You can either make them improper, yep, or you can turn them to decimals. Okay, so one or the other. For your homework, Connect Math is probably going to care. And if it gives you fractional bases and heights, it probably wants a fractional answer. So I'm going to show you how to solve this that way. Okay, so to convert, yes?
It's either recorded, I think the denominator is wrong and the 4.5.
Oh, you're right, it is. Thank you so much. That's supposed to be a 4th. I wrote it wrong. Thank you for catching that. Okay, so to convert to an improper fraction, or yes, so if I take 4 1/4 and I want to make that improper, I'm going to multiply and then add. So 4 times 4 is 16, plus 1, 17. And 2.5, Same thing, multiply and then add. So 5 over 2. And these numbers I can multiply. Is that good? Okay. Anybody have questions about this process at all? Or it's okay? All right. So then I multiply straight across. 17 times 5 is 85. 4 times 2 is 8. And this won't reduce. And as far as I'm concerned, this is a perfectly acceptable answer. However, they may want you to enter it on the computer as a mixed number. So if you entered this and they said it was wrong, you want to convert back. So to convert back, you divide. 8 goes into 8 once with 5 left over, so 0 times, and a remainder of 5. So this is 10 and 5/8. Okay, volume of a cone. This is a useful equation because if you fill the ice cream cone completely smoothly full of ice cream without a lump on top, you can tell exactly how much ice cream is in the cone. And then if you have the volume of a sphere, if you take the cone and you have the scoop on top, you can find both volumes and you know exactly how much ice cream you have. See? Useful. That way you can tell people, I only ate, you know, like 23 cubic centimeters of ice cream. That's not that bad. So, again though, if you don't like the fractional, this is the same as pi r squared h divided by 3. And this is the same as 4 pi r cubed divided by 3. Okay, so looking at that with the fraction, don't let that fraction trip you up. If you're not fraction friendly, you don't have to use them. This is known as a rectangular solid. You may also see it called a rectangular prism. Okay, so those two words are interchangeable, rectangular solid or rectangular prism. It's essentially a box, right? And a cube is a square box. And a cylinder is a can. And the formula for the volume of a rectangular prism and the formula for the volume of a cube are actually the same thing, because if I called this length, width, and height, this is the same thing. So remember, anything that's a cube and a rectangular, the formulas are going to be the same. So if you only want to memorize one formula, memorize the rectangle, and it will work for the cube. Okay, because every square is a rectangle, but not every rectangle is a square. And interesting little side. So we've got either length times width times height, or we can use side cubed because it's a cube. In any case, we're going to need to multiply these three numbers together, and I can't multiply mixed numbers, so I'm going to convert it. I'm going to multiply and add, and I'm going to get 3 halves. So my volume is 3 halves times 3 halves times 3 halves, or 3 halves cubed. However you'd like to look at it, they're the same thing. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. And it's feet, and it's volume, so it's cubed. So area, unit squared. Volume, unit cubed. And that's any unit. Centimeters, inches, feet, yards, miles, whatever. If it's area, you have to put a 2 over it, and if it's volume, you have to put a 3. And that's not on the number, it's on the actual units, the feet or the inches or the centimeters. And as I mentioned, if you're on a paper test for me, this answer is perfectly acceptable. It doesn't reduce, it's fine, it's done. But if you have to convert it, we'd say 8 goes into 27 3 times, with 3 left over. So this is 3 and 3/8. Still cubic feet. Volume of a can. We're going to use 3.14 for pi. So volume is equal to pi r squared h. 10 feet is my height. 1 foot is my r. So it's 3.14 times 1 squared times 10. So 1 squared is 1 times 3.14 is just 3.14 times 10. So it's 31.4 square feet. Okay. Or, sorry. Cubic feet. I'm getting my units wrong. Cubic feet. And if it's $35 a cubic foot, and I have 31 cubic feet, I need to multiply this $31 times $35. Or sorry, 31.4 times 35. And I have 1 decimal place, so it would actually cost me $1,099 to fill this tank with gas. A straight angle is 180 degrees. Yes, all the time. And it's called a straight angle because it makes a straight line. So a straight line is also 180 degrees. And a right angle is 90 degrees, and that is indicated by the little box. An acute angle is any angle less than 90. And an obtuse angle is any angle greater than 90, but less than 180. Okay, so once you hit 180, you're a straight angle. Once you go past 180, so you're like 181 or 182 or something, you actually start measuring from the other direction. So you're between 90, so at 90.1, you're obtuse, all the way down to like 179.9. And you're acute up to like 89.9.
So after you go around, it's actually becoming.
We have a property of vertical angles. If you have 2 lines that intersect each other, they make angles that are equal to each other. So C and D are equal. And then A and B are equal. So what you have is C equals D, A equals B, and then you'll notice I used color on this. If I add a blue one to a red one, you get purple. No, it equals 180 degrees. So A plus D is 180 degrees, A plus C is 180 degrees. B plus C is 180, but B plus D is also 180. because they make a straight line, right? Do you see that? So like if I take this straight line here, that's made up of A and C or B and D. So they make the two opposite pairs, if you take one of each of those, they make a 180 degrees.
So in other words, what you're saying here is basically we're speaking of vertical
Mm-hmm. Yeah, vertical angles. So these are equal, these are equal, and then any two that are different color add up to 180. So C and D don't add up to 180. I have no idea what that adds up to. It'll be different every time. But the two different color ones will always add up to 180. So the non-vertical angles, if you take one of each of those, add up to 180.
Because there are
Parallel lines. And we have something called alternate interior angles. That's 4 and 5, or 2 and 7. And the reason they're alternate is because they're on opposite sides. You don't have to write this one. I'm going to show you another one. You also have alternate exterior angles are equal. So what I've done is I've drawn a picture where we have L1 and L2. Okay? And I'm going to say that line 1 is parallel to line 2. This is the symbol for parallel. That way you don't ever have to write the word again. Okay, parallel. So line 1 is parallel to line 2. Okay. Alternate interior angles are equal. So green is equal to green, and blue is equal to blue. Those are the alternate interior angles. Okay. So inside our box here, inside we have alternate interior angles. Alternate. Here, hold on, I'll rewrite that. That's not very good. G angles, okay? And they're alternate because they're on opposite sides of this line here is called a transversal. Okay, so they're alternate because they're on opposite sides of the transversal. And then we have a theory that says alternate exterior angles are congruent. But that makes vertical angles as well. So those are equal. Oops, that's supposed to be green. And these are equal. So if you want to maybe, instead of making a color, you could draw a shape, like the blue ones could be squares and the green ones could be triangles or something. But on the outside, you have alternate exterior angles. And they're exterior angles because they're on the outside of the parallel lines. And they're alternate because, again, they're on opposite sides of this line. But what you end up having is two sets of 4 angles that are all equal. So all of the blues, we'll make the blues squares, maybe. And we'll make the greens triangles. Okay. All of the blues that I happen to make squares are equal. And all of the greens that could also be triangles are equal. And any blue and any green, if I add them together, equals 180. and we got that because this blue and this green equal 180, don't they? Because they make a straight line. So does this blue and this green, right here, same here and here. Well, if this green is the same as this green over here, then I could take this green and that blue, and it would equal 180 as well. So any blue and any green would equal 180. I'll draw my very beautiful lines. I give you a picture like this, and I say this one is 110 degrees. Find all the other ones. You can do that. Because this is 110, this is 110, and that's 110, right? And then I know that this plus this missing one over here will add up to 180. So that means this has to be 70, which means this is 70, which means this is 70, and that's 70. So you look at it and you go, I only have one number. You want me to find all those other numbers? That's crazy. But it's not so bad. You only have to do subtraction once, and then just copy things down for the rest of it. And that's why I like to put it all in one picture instead of in two different pictures like they did. But like I said, the ones I skipped over quickly are in the book. If you want to, you're more than welcome. I mean, go look at those. And if
Do you know what page in the book you find them?
not off the top of my head, no. They're in R4 though. So it's the first chapter, which is the R chapter, reference chapter, and it's section, if I can read it underneath. No, I didn't copy over correctly. It's during the angle part. Okay, so, oh, look at here. Wow, I picked the same number as they did. I didn't mean to do that. All right, we're going to label this one something different. We'll label this one 65. Okay, so if this is 65, what's this one?
65.
And this one?
65.
This one?
65.
That was hard, huh?
No.
Okay. Well, if that was 65, what's this one?
150.
All right, well, what's this one? Okay, this one? And this one? You guys made that seem so easy. Angle. It's cute. All the angles are smaller than 90 degrees. So it's cute. It's a cute triangle.
Cute.
It's a cute because it's little. A right triangle is one which has a right angle. And an obtuse triangle has one angle that is obtuse. So an acute triangle will be one of the ones that look like that. A right triangle, looks like this. And an obtuse triangle is one that has a big wide open bit. A 180 degrees every time. I am given two angles in a triangle. I can find the third angle in the triangle. So I have 40 and 110. So 110 plus 40 is going to be 150. And the triangle in total is 180. Yeah, so 180 minus 150 is 30. So this one's going to be 30 degrees. And then I have vertical angles. Vertical angles here and here. So if this is 30, this is 30. And if this is 40, this is 40. 110, and this would be 110, but, well, we can label it. But we don't know what E is, but we know that it'll make a straight line. So to find E, I'm going to do 180 minus 110. So it's going to be 70. And same thing to find C. I have these two make a straight line, and B is 30 degrees. So I'm going to do, it's B. So it's C, 180 minus 30. So it's 150 degrees.